the afternoon. Okay, good morning, everybody. Okay, good. Good. So, I want to talk to you today about something that is very personal to me. This thing happened in a company where I work. And you see, this story I'm about to tell you today is something that most companies, they don't like to talk about because it speaks of vulnerability in their platform. But this is a story I want to share to you all free of charge. You're not paying anything. I'll tell you this story. So, we lost a lot of money, several millions, within, I think, in less than a minute. A lot of millions of money was disbursed to these people that we don't know. But something happened in Joburg. When I delivered this session, I was on my way to Cape Town, and someone reached out to me.
Well, Paul, we really enjoyed your talk as well. Well, we were actually in the same team, but I enjoyed the fact that you were one of the only guys that was like very personified. A lot of movement, a lot of enthusiasm. It was really, really good. I can also see you know what you're talking about, with like your level of knowledge, but that enthusiasm, I really enjoy that because it shows that you really like what you do. So yeah, it was really interesting.
Thank you. So, let's give him a round of applause. I know by the time I'm done with this, what I want to tell you, a lot of you will still reach out to me again because I'm giving you what we call an expose. So, what are we talking about today? I really love moving around. This place is very, well, because they are taking a recording this, I love coming into the audience so you can feel what I'm saying. But I'll just try my best possible to stay within this angle. So, let's dive right into it. So, who is here in front of you today? My name is Paul Edward. I'm the CTO of one of the biggest investment firms in Africa, in West Africa, called AfriInvest. So we have over 5.2 million users right now using our platform. And I have over 12 years of experience. I started as a software developer, and I was very good at my job. And I was promoted to what? To the position of a CTO. Maybe can somebody give me a round of applause for that? I believe in the open source community. I've created open source application out there that is used by thousands of people around the world. We have some that has over hundreds of thousands of downloads. I have created a lot of security plugins that companies can embed in their code base just to make their code safe and secure. I have a tech community where I help people grow, mentor younger developers. I love writing. I love speaking, that's why I'm here, and I love building amazing stuff. I've built a lot of applications that are doing very, very great out right there. So I believe I'm the right person to talk about this topic, and I believe by the end of this topic, I'm going to what? Deliver. So what are we talking about today? Most of the time, we go to different restaurants, our favorite restaurants, to eat. Imagine you get to a restaurant, and the waiter, we have 50 hungry guests, and everybody is shouting their orders to that waiter at the same time. Can you give me a plate of rice? Can you give me a plate of pasta? Can you give me a plate? Everybody is shouting their orders at the same time to that waiter. Do you know what is likely to happen? There will be what? Chaos. There will be what we call duplicate order. There's a possibility that some table might not be served. There's a possibility that some table might not even get the right meal. And this is what happened technically. You have built your application. Everybody is excited about this application that is about to go live. We are all anticipating. This product is going live. It will be featured on probably on Forbes. It will be featured on several news media. And this application, you are thinking that you have built a fortress that nobody can penetrate. This is all the code are rightly done. Everything was just in place. You have the guards are on the door, the security on the door, but unknown to you that there is a very small entrance that people can still pass into your fortress, just like the wall of Jericho. So what happened when those kind of fortress, you have that kind of gate in front of your at that fortress is what we call a race condition. What is a race condition? It's a process whereby multiple threads, they are trying to access the same shared data at the same time. Just like in that restaurant, everybody is shouting their orders to that waiter at the same time. Can you give me a plate of rice? Can you give me a plate of pasta? Everybody is so, at some point, the waitress is confused that, please, can you guys just let me breathe? I don't understand what is happening anymore. You see this kind of stuff? It also happened technically as well. So many processes, so many threads, so many requests are coming to your application at the same time. And your application is like, whoa, I don't understand this request. I don't understand this request. What am I going to do? Then your application, it will start misbehaving. You see, this race is not something fancy. It's not something that is very technical, but it is just about timing. It's just about who gets there first. And this attack happens to a lot of applications that you see out there. A lot of them. And I have some statistics to back this up. In 2012, we have a trading platform that experienced this attack, and they lost 400 million within 45 minutes. Now, in that same year, a major IPO system lost over $40 million to this attack. And I don't know, maybe some of us have built an application and is vulnerable to this kind of attack. I'm going to do a live demo. I didn't do this in Joburg, but I think I'm going to do it here to simulate what a race condition is. So you can understand how this can, as subtle as that name is, it can get into your application. So let's take a quick dive before I go very deep into the topic. So I created an application. This is like a bank app. A wallet. So welcome, and probably you have a balance there, 400 rands. By default, I want to make a withdrawal of 500 rands. Immediately I click on this withdrawal. Can somebody tell me what will happen? I have 400 rands in my balance, and I want to make a withdrawal of 500 rands. What will happen? Huh? What do you say? It's what? I think I have a T-shirt for the person that gets the right answer. Let me see. Okay. I also came bearing gifts. Good. Okay, so sorry I had to step down a bit. So what will happen when I click on, I try to withdraw 500 rands? Huh? Insufficient fund. Who said insufficient fund? Please, just take any of your size. Yeah, I'm still going to take a round. Good. So, and I'm going to do that right now, and we'll try to see what will happen. Maybe it's going to say insufficient fund, or it's going to allow me. So, 1, 2, go. What is it saying? Insufficient balance, which is the right way an application should behave. Okay, let's try to probably add some money to our wallet, to our bank account, which I'm going to do now. So we have, let me make this 900 rands. Good. And save this. And I'm going to refresh this. Now we have 900 rands. So I want to make a withdrawal of 500 rands. What will happen? Huh? Huh? You get the money. Thank you. Who is that person? Good. Another T-shirt for you. Okay. So let's try that. Let's see. Maybe you are going to get the money. Wow. Withdraw 500 rands. Successful. So I did a notification system behind this, and there's a mail server kind of powering this. And can you see, I got a debit notification, which is, hi, you have withdrawn 500 rands from your wallet. But do you know that with this kind of attack, I can withdraw more than what I have in my wallet? We're going to simulate that right now. And probably when you get home, take these scripts and run it against your application. Let's give it a go. So now we have 400 rands. So we still have 400 rands, and we got the notification here just a few seconds ago. So let's make this 900. And good, let's confirm that this 900 is here. Good. Oh, so I've not saved it yet. Thank you. So we have, let's confirm this. Good. We have 900 rands. So I want to try to bypass this system. So I wrote a very quick Python script, which I'm going to show you all. And I think the Python script is, I have it here. Yeah, this is it. And I've added the endpoint here, and I'm telling this endpoint to probably just withdraw 500 rands from my 900. So let's go and run this script against my application that I'm thinking that is very secure. So I'm going to do that right now. I will run this Python script. Yeah. And let's go. Good. You can see a lot of insufficient fund, insufficient balance, insufficient balance, insufficient balance. But something happened here. Withdrawal of 500 successful, withdrawal of 500 successful. Another withdrawal of 500 successful, I was able to withdraw 1,500 rands from my account. So that means I should be able to get 3 email notifications, right? Now, let's go to my email service. As you can see, let's refresh this. Can you see a debit notification of 500, another debit notification of 500, another debit notification of 500, and I have just 900 rands in my account. Can somebody give me a round of applause? So the thing is, have you tested this script against your application? Do you know what I just did? This is what is called a race condition. I'm going to explain the code step by step so you can see how do we actually prevent our application against this kind of attack. Let's go back to our presentation. Please present. Good. Okay. Good. So I was talking about the costs of a race condition. But how did we eventually build an application that was subject to this kind of attack? Was that our intention? Did we intend to build an application where people can print free money on our platform? No, nobody wants to do that. Then I sat with the team. I woke up one morning. There was a lot of pages, a lot of notification. Paul, with money has been, we can't account for this money on our platform. People are busy printing money on our platform. God, I could not sleep that night. I was troubled. The whole team was troubled because these were millions that people were moving this money in a split of a minute. At the end of the day, we fixed this, but I sat with the team. I said, let's backtrack. What really happened? How did we build an application that is this vulnerable? Then I discovered one of the first things we did, we rushed this product to the market. We wanted to build an MVP, minimum viable product, but we ended up building a minimum viable panic. There was panic, there was chaos in the system. And you see, this thing goes to most of the CEOs, the CTOs, that you're always micromanaging your developers. You're always micromanaging people that are working with you. You're not you're not estimating the time it will take to complete a task. All what you're concerned about is the 1 and zeros. That 1 and zeros, instead of being added to your platform, might end up being deducted from your platform. So we rush this product to the market because we're targeting a particular date. So every time, when is this product going live? When is this product going live? You're behind your developers. And they're trying to tell you, we need to write this if statement with this. And you say, no, I don't understand what you're saying. I don't understand the gibberish you're saying. When are we deploying this application? This happens almost in every startups that I've seen out there. And every developer has a fair share of this story. You're trying to work against your trying to create something that is better than your competitor, and you're still rushing your MVP to the market. So shipping fast is very good, but when you ship something that is Flaw, you will pay for it. So one of the things that we did, one of the lessons that I want us to take from the mistakes that happened to us that we lost a lot of money is don't rush your MVP to the market because you might be cooking what we call your minimum viable panic. Move fast, but make sure that your application is secure. That was the first lesson. Secondly, when we discovered this thing, they got the call. What do we need to do? We needed to fix this. Because we can't just allow people to keep printing money on our platform. So what did we do? As a company, as a tech startup, as a company that you own a product that is in the market, one of the best investments that you can do for yourself is to invest in a very good monitoring tool. Because as human, most of us work 9 to 5. And after 5, we've gone on with other business of the day. What about your system? What about your application? Your application is live 24/7. Customers are using your application 24/7. And you see those guys that want to see how secure your application is. They are trying that application when you're sleeping. So you need a very good monitoring tool. Most people don't have monitoring tool. They depend on what we call logs, written logs that are not even visual to you. So we went back to our monitoring tool. As at the time then, we were using Inspector. Yeah, Inspector. And we backtrack it to as the time, we replayed it, the exact time that attack happened. And we discovered some unusual spike that wasn't just making sense. And we were able to single out the API that was faulty. Imagine if we don't have a monitoring system in place, we'll just be working in the dark. So, in as much you are trying to minimize the amount you're spending on your application, please, if you have an application that is out there, invest in a good monitoring tool. Most especially, even if you're not somebody that is technical, invest in the visuals, in monitoring that has good visuals that you can see, not just the one that are just strictly code, the one that you can see, at least they are written in English. We have so many tools that are like that, but I'm not here to market anyone. So, what did we do? Immediately, we singled out that endpoint, we patched it, we fixed it. How we fixed it, I'm going to talk about it. But guess what? We fixed this bug, and this was what we did. We introduced what we call locking system. I'm going to explain this in detail, but I think let me just talk about it now. What is a lock? Now, everybody is shouting the orders to that waiter in that restaurant at the same time. So, when you introduce lock to your system, do you know what it does? So, if all the requests are coming in parallel, like 10 requests are coming in parallel, like this, to your application, and you have added lock to your system, to that particular API that they are calling, do you know what that API will do? It will just, out of the 10 that are coming, it will just take only one. Only one will go probably inside probably that method or whatever you're doing inside the kitchen, do whatever it needs to do. The lock will be holding the other 9 parallel requests outside. So only one request will be allowed into the kitchen to do whatever it wants to do. So whenever it's done, it leaves the kitchen and signals the order that, see, I'm done. You can go in now. So what does that mean? I make the first now, I have 900 rands. Now I want to make probably 500 rands withdrawal. And the whole 10 requests are going into the kitchen at the same time. Then I just take one of it, make that deduction, and I signal the order that, hey, I'm done. When the second one is coming, as at that time, the balance has been deducted. So every other one we just check, hey, do I still have enough money here to make a deduction of 500 rands? He said, no. It kills the other requests. The other requests are just going to return insufficient funds. So we patched that API point, that API that was giving us issue. But guess what? We got attacked again. We lost some money again. Then we realized that this is not an API issue. This is an architecture issue. So we discovered that, imagine this all. you have so many entry points, so many exit points. People can go in through this door. People can exit through this door. People can go through this door, exit through this door. People can exit through this door. What does that mean? Is that your application, you can make withdrawal from so many endpoints. You can make some changes to your database from so many sites. That is a very risky way of building an application. So every time a developer comes into our organization, we don't have what we call a standard process. We don't have a standard procedure. Everybody just come, they build their own thing. So we employ a developer today, and we believe that they are very senior enough, so we give them the code base. Okay, we want to make a deduction from this wallet. They write their own code in the way that it pleases them. Another developer comes, they just do their thing in the way that it pleases them. But at the end of the day, we discovered the particular endpoint that we solved was actually safe, but they discovered other entry points to be able to make this withdrawal. So what did we do? The application got so complex, we decided to reduce everything to what? A single source of truth. We made it modular, and we created a service pattern. And what do I mean by a service pattern? Everything, let me take the wallet for instance. If you want to make a withdrawal from our platform, you don't need to write yours. Just use this particular code base. Just use this particular service. A kitchen where everybody can cook, where everybody is a chef. Nobody eats because you are expecting that the other person should be able to make their own food. So there was a lot of chaos in our system. Too many modules were doing these things. So we brought all those modules, brought them just to one service. So if you are a developer that you are coming into our system and you want to make a deduction, you don't write your own code. You just you just call an existing service that we have built. So what does that mean? We are solving that attack at a single source. We are not scattered all over the place. So we had to re-architect the platform just to make sure that we brought everything that are doing some complex thing to a single place. So what is the lesson that you can take from here? Have what we call standard procedures. Have SOP, way of operating. How do you want your developers to code? Don't just assume that this is not micromanaging. This is you setting up processes for your company. Get somebody that is senior enough to help you create standard of operating, the way your developers are meant to work. They should not be left in silos. We did that, and we lost millions for it. Now, because this application is still live, we are still fixing all these things. We brought everything to a single source of truth, and we pushed that to life. Guess what? We were not attacked this time. We were not attacked this time. But what am I trying to say? As complex as your code it can be, you need a single source of truth. When everything is scattered, it's very hard to manage. I know we want to push out. Now, we're in the era of vibe coding. And what does vibe coding do for us? We can easily push our MVP in less than a day. But are you actually checking how complex your logic are? So when the code start getting complex, make sure you consolidate everything, create several services that can help you manage things that are very risky in your business. So what did we do? We added locks, which I just explained what lock does. We added what we call atomic operation. And what do I mean? I'm going to still explain what this atomic operation is. We also added row-level locking. But what you are currently seeing on the screen right now is still trying to emphasize that you should kind of make sure that all your code, everything that you're writing, are kind of consolidated. Because when chaos ends, when you control who enters, if you probably there's definitely somebody at the door before you get in. You know what that person is doing? That person is like a lock. They control who enters probably this room. If you're not entitled to come into this room, they stop you at that door. Your code should have that kind of logic. Then let's move on. So what is atomic row-level locking? And what other things did we do aside from lock? We added something called rate limiting. What is rate limiting? Let's take, for instance, many people don't pay attention to this. Trust me, I've consulted for quite a lot of company, and one of the first things I'm correcting when I'm auditing their code base is this. Can you tell me why your withdrawal endpoints? Or can you tell me why an endpoint that is doing something very, very fragile on your platform, why should I be able to click that endpoint 100 times in a minute? Am I a bot? Why did you allow that kind of stuff to be able to, I can click that endpoint 100 times, 50 times, 10 times in less than a minute? Only bot can do that. But are we protecting our applications against those kind of attack? Most of the time, no. Some of the time, yes. So those withdrawal endpoints, those sensitive endpoints that we have increased their rate limiting to something very large. At that point, we added, I think it was 600 calls per minute. We just left it with the default that came with the framework. We didn't touch it. So anybody can set this kind of bot to our application that run this API, run it 50 times, because those are what we call parallel requests. Those things are what we call race condition. They are all racing to make your application confused, so they can do anything they want. So we limited the kind of calls you can. At least I think we reduced it to something like 3. If you want to make a withdrawal from your platform, from your account, why? We can allow 2 and call that an error. Maybe that was a double click. But the 3rd time, people are actually very careful with their money. Somebody that is going beyond 5 is up to something. So we added rate limiting. Then we also added what we call idempotency. What is an idempotency? Sometimes we double click on our platform. Imagine you want to withdraw 500 rands from your account, and mistakenly you double clicked. You're not expecting 1,000 rands in your bank account. You're just probably expecting 500 rands. So we prevented that by making sure that when you click on something multiple times, it gives you the same request as the first one. So if I'm withdrawing 500 rands and the bot is double clicking and you are not adding some of the right parameters that we have set there, it gives you the same results. So you would think that you're actually playing with the system, but the system is not only the first request will be honored. Every other request will be nulled. So we added the idempotency and making sure that the kitchen only serve 1 dish per order. Let's move on. Now, locks are very good. We've introduced lock to make sure that only 1 entry can go in at a time. They are very good. They are very awesome. But it is something that you have to use judiciously. Lock is not something that can save you if your logic is broken. And I'm going to explain. We have 3 methods here. The first one is to check your balance. The second one is to debit from your account. And if you look at the second method, which is the decrement wallet balance, that method is very safe, because there's a lock system there, very safe, very okay, it's fine. So like this, we are protected. Then we have the third option, which is process transaction. So what does this process transaction do? It checks the balance and it then makes the deduction, which logically that makes sense. But I will tell you today that you see this code, don't try it at home. It's very vulnerable. And what do I mean? You see, if you look at the third method, you see when the third method is being called, there is it's checking the balance first, then it's deducting like this. The arrangement is like this. And it's not supposed to be like this. It's supposed to be like this. You see like this? When you send a race condition against this type of code base, you see, when the first process, when it gets hold of the first method, trying to check the balance, the other process will skip. Because that first one is busy, the other process would just go directly to decrement your balance without checking if you have money in your wallet or not. Because they are arranged like this. So what you're supposed to do is to make this kind of process atomic. Make sure that the lock comes before you even check your balance. So you are telling everybody, see, hold on. How much do I have in my bank account? Say 500 rands. Okay, come in. Hold on. So the lock should be before you do anything, not after you are checking your balance. It's a very dangerous way of writing code. This, as neat as it is, it's actually broken. Now, like I said, the lock can save you if your logic is broken. I want to try to make this fast. So, another thing we did was to make sure that we added row-level locking, making sure that any operation that we are doing is very atomic, just like I explained earlier. So how did we secure this system? We made sure that we added the tempotency, rate limiting, made everything very atomic. Now, aside from the monitoring tool, then we added some alert system. I built an open source package for idempotency. I think I did one for Python. I did for JavaScript. Everything is on my GitHub. Once you install, it automatically sends you a notification when somebody is trying to send this kind of attack to your platform, if you have it installed. So you are supposed to set some real-time anomaly detection in your monitoring tools, whatever monitoring tools that you are using, so it can send you the right notification that, hey, somebody from this IP, somebody from here is trying to access your system. What should I do? You can set those kind of flags. So we added all these flags in the right places. We set up a very good standard procedure for the developers, for the product owners. We added what we call point system for the developers. So it is not just about you. First of all, you get a point when you estimate your time rightly. So, okay, this time is going to take me 2 days. You get a point when you deliver within that time frame. You get a point when that product is being deployed. You get a point, and at the end of the day, all this point system is tied to your appraiser. And we also have a clear book for incident response. Now, security is not just a checkbox. It's not something you just... it's something that should be baked into your system. Because you see these guys, you see these bots, they are not sleeping. They are awake 24/7. And they are more agile than you. They are faster than us. But most of these breaches, they are not most of the time complex. Sometimes they come from assumptions, thinking that you are filling all the gaps. Some of these breaches come from maybe neglect. So submit your code base to a VAPT test as well. If the one your developers have missed, they might not miss it. You understand? So that is actually the real race. This race is a race in the conventional world. That race is a race that you want to win. But you see, technically, that race is a race that you don't want it to win. Because if it wins, something will be broken. And I'm not a ghost. My name is Edward Paul. Scan this just to prove that you've paid attention to everything I've said and rate my talk. Thank you very much.